Hi everyone, my name is Claudia Kemp and I am going to be teaching the Module 2 lesson on Chapter 9, Geometric Figures. Number 1 talks about parallel lines, like in the American flag. Parallel lines are lines that are equal in distance no matter how far apart they go, meaning they will never touch one another, just like the red stripes or the white stripes are in the American flag. It's also a parallel flag. This problem gives us a diagram starting with lines 1 and 2 and says that lines 1 and 2 are parallel, but they also have these lines intersecting them. And it has all these angles within it, and we are to define the angles and their relationships with one another. So these angles right here are measured for us instead of numbered. So first we need to define the organization levels of these angles. First we have complementary angles. Complementary angles are angles that when added together equal a perfect 90-degree angle. That's not going to be perfect, but now we can see in our diagram that we don't have any 90-degree angles. Therefore, we do not, here, hold on. Okay. Therefore, we don't have any complementary angles. Next, we have vertical or similar angles, and these angles are angles that parallel each other or that are equal. So you see 2 and 4 parallel each other and they're the same size, and 1 and 3 mirror each other and they're the same size as well. So we can look at the line 1 half of the graph and we see that angles 1 and 5 mirror each other, angles 3 and 4 mirror each other, and angle 2 and the 63-degree angle mirror each other. So 1 and 5, 2, 63, and 3 and 4. Next, we have supplementary angles. Supplementary angles are angles that when added together equal a straight line, 180 degrees. As you can see here, angle A and B make one straight line. Looking at line 1 again, angles 1, 2, and 3 make a straight line, and angles 4, 5, and 63 degrees make a straight line. So those are the definitions of these angle terms. Next, we have to organize these angles. As we said before, complementary angles, there are none in this graph. But supplementary equals a straight line. So we have 1, 2, and 3, 4, 63, and 5, 6 and 61, 7 and 8, 9 and 10, and 11 and 12. Those sets are all supplementary. Similar angles or vertical angles are the ones that equal or mirror each other. So we have 1 and 5, 2 and 63, 3 and 4, 6 and 10, 7 and 12, 61 and 9, and 8 and 11. And those would be the similar angles. And that's number 1. Number 2 gives us this triangle with the line PQ and line QR drawn into it. And it wants us to define all of these different angles that it has not given us a measurement for. So the first one that you would do would be number 1, because you would just complete the triangle, which is easier than it sounds. All 3 points of a triangle, 1, 2, 3, are to equal 180 degrees when added together. So you would take 76 and 31, add them together, and subtract that from 180, and you would get 73 degrees. So angle 1 is 73 degrees. Next, you would do, next I extended these parallel lines so that you can better see the relationships between the angles, and you can see that angles 3 and 8 are similar to angle 1, and so they would also be 73 degrees because they're in the same spot on the lines. They're the same relational spot. Next, you can see that angle 2 is supplementary to angle 3, so it would be the difference between it and 180, and that is 107. And then next, you would see angle 5 also mirrors these angles, and so it would also be 73 degrees. And next we have angle 7, which is the supplementary angle of angle 8, which equals 107 degrees. And then finally we can see that angle 4 is mirroring angle B, which means it is 31 degrees. And angle 6 is mirroring angle C in relation on the graph, and so it is 76 degrees. And that is how you would complete that triangle. Next, we will organize them between complementary, supplementary, and similar or vertical. Here's all the angles again for reference. We know we have no complementary angles because it was not a right triangle. So no complementary angles. Supplementary are the ones that added together equal 180. So we have angle 1 and 4, 73 and 31. Angles 3 and 4, 73 and 31. Angles 5 and 4, 73 and 31. And 8 and 4, 73 and 31. So there was a lot of similar angles there. Let's move on. Angles 1, 3, 5, and 8 are all 73 degrees. And then angles 2 and 7 are 107 degrees. So that is number 2. Number 3 gives us this shape right here and asks us to define the degree of all of these angles right here. So the first step to defining the sum of interior angles is to use this equation right here. N minus 2 times 180 is the sum of all the interior angles of a shape. N is the number of sides in that shape. So we have 1, 2, 3, 4, 5, 6, 7, 8. It's an odd octagon. So we would have 8 minus 2 times 180, which is 6 times 180, which is 1,080 degrees total. Next, you would try to define y. So you would add all of these different pieces, 3y, 11y, 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 3y, 15, 15, and 3y again, 15y, 15y. And you would ultimately get 72y, and then you would solve for y, which equals 15. So then you would take your value of y and plug it in to all of these variables right here, and you would see that the 3y angles here, here, and here are 45-degree angles because you plugged in the value of y. The 11y angles, these top three, are 165-degree angles, and the two 15y angles are 225-degree angles. Next, we need to go to number 4. And number 4 gives us an actual octagon and asks us to determine the angle of the central, the outer, and the interior angles. So again, interior angles will be n minus 2 times 180 divided by n because they are all equal. N, again, is the number of sides, and again, it is 8. So we have 8 minus 2 times 180 divided by 8. 6 times 180 divided by 8. 6 times 180 is 1,080. So 1,080 divided by 8 is 135 degrees. So each of these angles represented by this one right here, 1, 2, 3, 4, 5, 6, 7, 8, all 8 of them are 135 degrees each. Next, we need to find the exterior and the central angles. This is done by dividing 360 by how many sides you have, or n, which again is 8. So 360 divided by 8 equals 45 degrees. So this angle and this angle both are 45 degrees. Number 5 gives us this cube and wants us to draw on it, basically. So it asks that we first draw a tetrahedron using D, E, G, and H, and it would look like this. And then next it wants us to draw another one, but without using the same faces, and so within the inside of the cube. So then it would look like so, because it is never using one of the actual faces of the cube. It's always going through them, and it's in the inside of the cube. It's not perfect. Number 6 asks us to draw legal diagrams for the tetrahedron first, which is 4 triangular sides, or 4 triangular pieces. And so it would be like so. You have 1, 2, and 3, and then the bottom would be 4, like a pyramid. It's 3D, 3-dimensional. Next is the octahedron, which is 8. So we have 1 on the top, 2, 3, 4, 5, 6, 7, and then the bottom is 8. And the isosahedron is the last one. It is 20 triangular faces. So we have 1 on the top, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh, I missed one. Let's recount. No big deal. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and the bottom is 20. But it would look like so, divided as well as possible. And last, I have a geometry joke for you, a little bit of geometry humor from the complementary angle. And thank you for watching my presentation.